So I hope you understand now. First question, how web application firewalls are different than next generation firewalls, right? So next one here, why do some sessions show a session ID 0 in traffic log? So pre-security policy check, drop packet if not meeting criteria. So session is not created. Session is created only if security policy allows packet, right? So if any packet or traffic is denied with the security policy, the first packet of TCP three-way handshake means like no session ID number, right? So if I just show you, so let me open this log message here. So look at the session ID here, 0, action deny, and action source is what? From policy. And application is not applicable. Why not applicable? I'm going to explain that. And the rule interzone default, source IP, country Indonesia, source port address, interface Ethernet 1/2, and session end reason, policy deny, and how many packets received by the Palo Alto firewall. So only one packet, right? So you can find like details in details section. Session ID 0. Let me send one packet from a computer behind the Palo Alto firewall. Randomly, I'm going to type any IP address here. Let's say 43.205.28.maybe 48, port number 22, SSH, right? IP address and port number 22. And let me show you a security policy also. The security policy here on the Palo Alto firewall. So only DNS, Facebook, Gmail, Google based, Telnet, right? These applications are allowed. Okay. And what about other applications? They are not allowed, and there is one incoming RDP, interzone default. So now if I go to monitor and let me put a filter here, destination IP. So I tried to head down 43.205.28.48 IP address, apply filter here, and this one, look at the log. So session ID 0, deny from policy, drop only one packet, yes. And what about the application? Not applicable. Why not applicable? So as I said in like question number 1, that TCP based applications are identified after three-way handshake. So once connection is successfully established, then application is identified, right? And no matter whether application is like HTTP based or HTTPS based. TCP based application means first packet TCP SYN, no data, IP header and TCP header, right? So first packet of TCP three-way handshake is controlled on the basis of layer 3 parameters like IP and layer 4, that is TCP. Source IP, destination port, flag, right? And if the first packet is not meeting the criteria of security policy, not allowed, dropped or denied on the basis of destination port address, means application column will show here like not applicable, right? Because no data here, no three-way handshake, no application data. So there is no point of applying app ID signature here. Understood? What if three-way handshake successfully done? The fourth packet, the next packet that hits the firewall. In case of HTTP, the next packet means what? HTTP GET request, right? Now firewall will look at the layer 7 data like HTTP header, deep packet inspection to identify application identified but not allowed in the security policy, then again dropped, but after three messages, after three-way handshake, right? So if like the very first packet not allowed, so definitely not by using app ID, just on the basis of IP or TCP port address only, right? And session ID 0 means session is not created, session is not allocated, session ID is not allocated. But if we see like traffic log with session ID 0 means traffic reached to the security policy, because before security policy check event, a lot of other policy are checked. Like if I start from starting, so basically first ingress state check, right? Ingress, and then tunnel de-encapsulation in case of fragmentation, then defragmentation or IP defragmentation is done, right? And then zone protection kicks in. If like the zone protection profile, TCP state check is also done, like if the first packet and flag is not SYN flag, then again dropped. And after that, forwarding lookup or routing table lookup, forwarding lookup, and then you let me erase this. I need space. Okay, so forwarding lookup, and then what next now? NAT policy lookup, NAT policy lookup, even user ID, DAS protection profile if there is any DAS protection, and then finally security policy and even pre-security policy check. The security policy is only for based on IP and ports only, right? So what if like there is no like route for the destination IP, routing lookup is not done successfully, maybe TCP state check error, dropped with zone protection profile, so definitely you will not find any traffic log there, right? It means if we see log in the traffic log with session ID 0, then at least like all like checks done prior to like hitting security policy was successful, right? But since security policy doesn't allow the first packet based on IP or port, so session number or session ID is not allocated. So we see like session ID 0, simple, right? Let me go to the next one. Why does the traffic log show application as incomplete, insufficient data? So incomplete means only two messages are exchanged in the three TCP handshake, right? No like successful three-way handshake. Insufficient data, no data after three-way handshake. Three-way handshake successfully done and then no data is exchanged. And application identified, yes, like data after three-way handshake, but there can be shift of applications, and generally it happens in case of sub applications, initial like base and then some sub applications. As more data comes in, for example, application initially identified as Facebook base and then later on Facebook chat, or maybe Google base and then some different application of Facebook base, then Facebook game or Facebook upload. So Facebook chat, Facebook upload, they all are sub applications, right? So yes, like there can be application shift also. And not applicable means like no data was found in the packet, and will happen with TCP based applications, mainly TCP based application, because you understand like UDP based application means first packet, yes, there will be data, IP header, UDP header, and then data, right? And the interesting one, what are the reasons that the firewall drops a packet without showing anything in the traffic logs? And before that, before I go to like answer the next question, question number 4, let me show you another very important stuff here. So let me clear this. So you can see here like policy, YouTube is not allowed, Twitter not allowed. So what I'm going to do, I'm going to access youtube.com, right, from a computer behind Palo Alto Firewall. And let's see what we find in the traffic log, whether session ID 0 or session ID number, what about number of messages or packets like received or exchanged between client and server, what about this application column, not applicable or incomplete, insufficient data, what like will be the application. So I'm like on the machine, right, and computer is behind Palo Alto Firewall, and I'm going to open here application youtube.com https based application, port number 443, right, not allowed with the security policy. So we're not expecting success here, right? Application blocked, yes, the application you are trying to use has been blocked. Please contact your system administrator if you believe this is an error, and IP address here. All right, and now I'm back to traffic monitor. Let me do a very quick refresh here, and you can see here application identified, YouTube base, right? And what is the type? Deny. Port number 443. Let me show you the traffic log here. Double click. Look at the session ID number this time, 388. Action deny from policy, application successfully identified, YouTube base. Now this time matched with the inter zone default policy. And what about the packets? So detail, and you can see like the bytes sent and received, 875 bytes sent, received. So we can see like more data coming in here, right? And risk level application, YouTube. So why like session ID number is allocated, and we see like number of bytes here and this traffic log. So because initially what must have happened, like in case of YouTube, first is Palo Alto Firewall, external interface, internet, internal. What I tried to open youtube.com. So first step here is name to IP translation, DNS name resolution, either by using any internal or local DNS server or external DNS server, and then TCP three-way handshake, right? And then on top of that, SSL handshake. And once like SSL handshake is also successful, then we can see like data coming in and going out, right? So first TCP three-way handshake and then SSL handshake, because YouTube, we all know like HTTPS based application, secure HTTP, right? Secure. Now, after 3 messages, like the fourth one, and during initial 3 messages, in fact, Palo Alto Firewall was not able to identify application, and that is why all 3 messages were allowed. permitted, right? Why? Because three messages means only IP and TCP header. So initial three messages can be controlled only on the basis of IP address or port address, right? No app ID, no application ID, no matter like whether your firewall is next generation or traditional or legacy firewall. But there are some mechanism like like a lot of SD-WAN appliances are using nowadays, like first packet application identification mechanism. That means like identifying TCP-based application from the very first packet, also maintaining like some application caching locally in the firewall itself. Application caching. Palo Alto Firewall also does like application caching, and a lot of like SD-WAN appliances, Silver Peak, 14.8 even, they have first packet application classification mechanism. Means like initial when DNS request is sent and DNS reply, like that comes like from DNS server. So generally the devices, SD-WAN devices, they just open the DNS response packet and then they start doing caching, right? Caching means like maintaining a database, like domain name this and then the IP address, domain name this, then the IP address. So like obviously they are also using a traditional method of application identification, like deep packet inspection, that is DPI, IP, port, plus these new techniques, right? That's what like first packet application identification mechanism is. But let's not get into that discussion. First packet application identification. So in general, in case of like even HTTPS, after three-way handshake, after three messages exchange, the fourth one, the fourth packet is SSL client hello packet, right? The fourth packet, or you can say the first packet of SSL handshake, because a lot of messages are exchanged in the SSL handshake. So the first packet of TCP, sorry, SSL handshake means like version and cipher suite, session ID, some other session specific data, and SNI field there. A name here youtube.com, right? And firewalls, next generation firewalls, they just read this information from SSL client hello packet, the first packet, right? And no matter like what the application is, irrespective of that, this first message is checked. And if firewall like then definitely firewall would have definitely dropped that, because seeing like youtube.com, because in security policy YouTube not allowed, but till that time already three messages had been exchanged. That is why like there is session ID number of bytes or counters increased, right? But once firewall realized I did wrong, I committed mistake, I mean like I did something not very good, because initially I allowed three messages, I thought of like uh, heading TCP port 443, but since now I have identified that the application is YouTube and YouTube is not allowed, so no way, you cannot go, right? Drop there. So make sense? Okay. And the next one, most awaited, very important. What are reasons that the firewall drops a packet without showing anything in the traffic logs? So let me simulate this problem first, and then I'm going to explain like the whole concept. I mean, not only the answer, complete explanation with demonstration, right? So just I'm trying to simulate this problem. So here there is a Palo Alto firewall external interface that goes to internet, and Ethernet 1/1, Ethernet 1/2/2 is in outside security zone, inside security zone, and for lab demonstration purpose, there is one client machine, and client machine IP address is 10.1.1.200, right? And client is pointing to Ethernet 1/1 interface of Palo Alto Firewall as a gateway. So Ethernet 1/1 interface IP is 10.1.1.175. So basically 175 is gateway for internal computer machine. Let me quickly show you like existing security policy, NAT policy on the Palo Alto firewall. So if you look at the policy here, so inside to outside, DNS, SSL, Telnet, and web browsing, all four applications allowed, right? With the security policy, and also there is one source NAT policy. Source NAT, dynamic IP and port, original packet, any IP from 10.1.1.0/24. And if you look at the translated package section, dynamic IP and port, right? All good. Security policy, NAT policy. Let me show you client machine configuration. So it's a client machine and it up to settings, properties, TCP IP. So look at the IP address here, 10.1.1.200, 10.1.1.175 is Palo Alto Firewall IP address, right? So what I'm going to do, I'm going to telnet internet IP, internet-based destination IP from this computer 12.0.1.28, right? Route server IP, port number 23, telnet. Telnet is allowed with the security policy. So hit down, open here, right? So we are trying to establish telnet session with 12.0.1.28 from inside to outside. So Windows computer is in inside security zone. IP address is 10.1.1.100. Gateway is 10.1.1.175. And network error, connection timed out, not successful. If we check the monitor here, sourcing with IP 10.1.200, destination 12.0.1.28, no traffic log as such, right? No traffic log. Now let me open whiteboard one more time. So telnet is allowed with the security policy. There is proper NAT policy. Telnet connection not successful. We cannot find any traffic log, right? So no traffic log in Palo Alto firewall. In fact, traffic is not passing through, but the message here is denied. So what's the reason and how we can do troubleshooting, right? So we are trying to find out answer for this question. What are reasons that the firewall drops a packet without showing anything in the traffic logs? So see the explanation and then I'm going to practically show you that as well. Firewall puts something in traffic log only if it hits security policy. So if there is no route and packet is dropped, log will not show anything, maybe routing issue or maybe some issue with TCP state check, right? Maybe IP option failed or some other like error in layer 3 or layer 4 header even, maybe invalid combination of TCP flags, because these checks are done prior to matching traffic with the security policy. So not necessarily a routing issue, can be anything. I mean like maybe TCP state check, ingress in stage error, or maybe your what do you call a DAS protection policy, zone protection profile, right? Check some integrity check issue, or maybe no entry in the session table and also not a first packet can be another reason. So there can be like multiple reasons for that, right? So if we don't find anything in the traffic log, there can be multiple reasons. But let's first understand like the flow logic of Palo Alto Firewall, a very high level overview, because already I have covered so many times like flow logic, Palo Alto Firewall, packet flow, just a very high level overview in order to answer this question properly, right? So I'm back to the whiteboard. Let me draw Palo Alto Firewall here, right? Palo Alto Firewall, and mainly the slow path, fast path, offloading. I hope you understand all this, right? A client machine here and server internet site. Server IP 12.0.1.28, client IP address 10.1.1.200. First packet of TCP IP is what? TCP SYN message, right? IP header and TCP header. IP header means like source IP here will be 10.1.1.200 and destination IP 12.0.1.28, right? And the protocol number for TCP is 6, TTL value, checksum, length, IP option field, D of bit, right? But we are not going to talk about like all like fields of IP header, because IP header means like 20 bytes, not relevant, even not important. And same like TCP. TCP mainly we are going to understand like the destination port address and the flag. So destination port here 23 for telnet, and flag TCP flag is SYN, right? The first packet. Now interface Ethernet 1/1 inside in Ethernet 1/1 is in inside security zone, right? Layer 3 interface basically. So what firewall does now? Obviously, firewall will check whether the packet is the first packet or like already session has been established and the packet is not the first packet. It matching with existing session in my session table, right? So what firewall does, in fact, it performs some flow logic, check like whether there is any information about this in the session table or not, right? Based on the outcome of flow logic, and then it is enqueued. I mean, like then it is now subjected to the firewall security policy, right? And prior to that, a lot of other checks, obviously. So since the packet is the very first packet, as there is no entry in the session table, right? So no information, no entry in session table. So what next now? Next here is after performing ingress stage, I mean like layer 2, layer 3, layer 4 informations are extracted from the packet, and layer 2, layer 3, layer 4 all checks are done at ingress stage, in fact. And let us assume that there is no error, everything is up to the mark, in good shape. IP header even like no mismatch of uh, uh, in fact ether type field in layer 2, layer 3, let's say TTL is non-zero value, even the protocol number, other checks done properly, IP option field, source and destination IP, whether they both are same or not, packet is truncated or not, all done. Let us assume successfully done, no issue with layer 2, layer 3, layer 4, like ingress stage after doing parsing and all that, right? In case of fragmentation, yes, like defragmentation done. In case there is zone protection profile, that is also checked. First packet, then obviously the flags would be sent. So all like up to the mark, good, right? So now here in this slow path, in fact, what happens first here? routing table, after doing like all the checks, in fact, routing table or forwarding lookup is done here. Forwarding lookup in the this I've taken the example of a new session establishment, right? A new session, in fact. Forwarding lookup, and in forwarding lookup also like preference is given to policy based forwarding and then virtual router routing, right? Forwarding lookup is done, and then the next one, after finding out matching route in the routing table, then NAT policy lookup, NAT policy lookup. Then in case of user ID, DAS protection profile, I'm not going to take like all zone and DAS protection profile into the discussion. And then security policy, pre-security policy match. Pre means like security policy means like here application is treated as any. So only basically IP and port based, because application any. So why routing table lookup is done before NAT or security policy lookup in Palo Alto Firewall? Because Palo Alto Firewall, as we all know, like a zone-based firewall, right? And in order to create any session, source IP, destination IP, protocol number, source zone, destination zone, right? Source port and destination port, all six tuples like source IP, destination IP, source port, destination port, protocol number, source and destination zone, all six tuples should be known. Without knowing all six tuples, session cannot be created, session ID cannot be allocated, right? So firewall knows like the source IP, destination port, also the source port, also protocol number, even ingress zone known, ingress zone is known, right? Because ingress zone is like inside, protocol number, source port, destination port. What is missing here? Destination zone. So in order to identify destination zone, exit interface should be known, right? Exit interface. And how like exit interface can be known, can be identified after performing routing table lookup, right? So if firewall finds a matching route for 12.0.1.28 and exit interface is Ethernet 1/2, so now like destination zone is also known now, because Ethernet 1/2, like this one, outside interface is in Ethernet 1/2 outside security zone, right? Egress interface and this like packet flow, egress, I'm sorry, egress. So in order to identify like egress zone, routing table lookup need to be done, because whether we are like creating NAT policy or security policy or any other policy right? We take their like zone like source and destination zone. So that is why NAT and security policy lookup done like after finding out exit interface. Now, what if packet is now dropped with like routing? I mean, like no matching route found in the routing table, right? Packet dropped, packet not reached to the security policy, dropped before. So will there be any log? No, not at all, right? So if packet reaches security policy, not allowed even, right? Based on IP and port, deny it, but we'll find a log there. If logging is enabled, so with session ID 0. And if after performing pre-security check, I mean like checking or maybe taking decision based on IP and port allowed, session ID number is allocated, right? Then definitely we'll find session ID number there in the traffic log. So most likely if we don't see any like log in the traffic log section, right? No log, silent packet drop, firewall drops the packet silently, means no log there. So reason can be either like some ingress error check, ingress stage error check, layer 2, layer 3, layer 4 parameters related issue, invalid combination of TCP flag, maybe packet is truncated, or like TTL value 0, protocol number 0, port number 0, right? In any issue with that. Or maybe drop with this TCP state check, first packet, but flag is not seen. So what firewall will do now? And this may happen because of asymmetric routing, or maybe some another, like flooding attack or something, SYN attack, or uh, not SYN attack. In fact, for SYN attack, yes, like this would be zone protection profile or some other profile to protect like from these attacks. So because of any reason, if packet is not reaching to the security policy, not dropped or allowed with the security policy, means no log there. Now how we can do the troubleshooting, right? Obviously we can do packet capture, we can see a global counter from the CLI, even if required, then we can do a debug also, right? Let me open partition. All right, so let me run the command debug data plane packet diag show settings. Is there any settings here? Packet filter enable, no. Pre-parse packet, no. Logging enable, no. So not enable. So I'm going to run debug data plane packet diag filter. I'm going to first use a filter here, match source IP. Source IP is 10.1.1.200 client IP address. And what about destination? Destination is 12.0.1.28 and destination port 23 telnet, right? So I just created a filter here, debug data plane packet, and even like filter can be created from graphical user interface mode as well. So, and I'm sure you must be knowing like how to create a filter and all that, like packet capture even we can do from graphical user interface mode, or maybe from CLI also. And then I'm going to set filter on, so filter is now on. And also I'm going to enable debug data packet tag set log on. Logging is also on, in fact. All right, and can we do verification now? Debug data plane packet diag show settings. So packet filter is enabled, first filter is created, index number this. We can also do verification from graphical user interface mode also, right? So packet capture, and you can say this. There is one filter, 1/4 filtering is on. So what I did, I created a filter, and even we can verify the same from graphical user interface mode also, source interface, source IP, destination IP, and destination port, right? So we can create filter either from CLI or from graphical user interface mode filtering is also on, and let me now again initiate this. And what about show counter? Let me also check this counter. Global filter severity drop. So package drop tag not configured, no destination zone. Some multicast packet drop I can see here. Let me also put here global filter delta, yes, and then severity drop. So command with delta option, this allows viewing packets dropped since the last time the command was issued, right? So delta spelling mistake drop. All right, so I'm going to initiate connection one more time, restart. Packet like debug is on already, and can we, so flow policy, no forwarding, session setup, no destination zone for forwarding, no route for IP multicast. All right, so wait here, and now I'm going to turn off this data plane packet tag, and set log off, log is disabled, and now I'm going to aggregate the file. Packet tag aggregate logs, and aggregated in the file pan packet dag.log. So we can use the command less command packet underscore tag.log. So I can see here like packet decoded dump layer 2 information extracted from the packet type 0x800 ether type, basically source IP, destination IP, protocol number 6 for TCP, version is 4, type of service obviously not configured for QS and all that, TTL is good like 128, checksum here, fragmentation bit is off like DF bit, basically no like do not fragment bit, and then TCP header, source port and destination port, sequence number, acknowledgement, and the flag is SYN, so looks good. TCP options and session setup, virtual system 1, policy based forwarding lookup with application none, as I mentioned before, pre-security policy check, packet dropped, no route during session setup, right? So packet drop, forwarding info unavailable for policy lookup. So in order to do policy lookup, there has to be destination zone, and destination zone means egress interface. And to get egress interface, this routing lookup must have been successful. So packet dropped, and the reason is what? Session setup failed. So because of this reason, packet dropped, right? So even like we can use like packet capture also. We can also do packet capture to troubleshoot this kind of issue, because if in packet capture, if you see like a captured packet in maybe received or dropped but not forwarded, so obviously like very easily we can reach to the conclusion. Even we can also use like this global counter like command like show counter global, and then you can use filter, like let's say we want to see only drop packet, So you can run this command multiple times here. So output is also very informative here. So you can check the value here, and the description is also there, right? So if packet is dropped before reaching to the security policy, means no log, right? So I hope you understand like this question also. What are reasons that the firewall drops a packet without showing anything in the traffic logs? Maybe like first packet, but flag is other than same, then again same result. Or maybe check some or integrity check issue or routing issue. Okay. So far we have covered four questions of this Palo Alto Firewall troubleshooting based interview questions, right? But it has many more questions, so we'll discuss in the next session. So first, second, while some session show session ID 0, incomplete, insufficient data, and what are reasons that the firewall drop a packet without showing anything in the traffic logs, and then HA1, HA2, zone protection, and the most super important, interpret VPN error messages, right? So we'll spend good amount of time on this VPN troubleshooting. Okay.